Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 7.7 on factoring special products. And we asked the question, how can you recognize and factor special products? Well, if you think back to lesson 7.3, so a week or so ago, we did a lesson on multiplying special cases of polynomials. Now, this is kind of the reverse lesson. What do I mean by that? Let's take a look. We have the one pattern we look for is called the difference of two squares. And it's exactly what it means. And that is, I have a square. Usually the variable goes first, squared, variable squared, minus another square. In this case, a square number. And we know that when we multiplied the sum and the difference of the same two numbers, we got a difference of two squares. That's one of our special case multiplying of binomials. This is factoring, so we're going to take a look at this and go backwards. How do we do this? Well, we take the square root of the first term. I'm going to write it this way. I'm going to put two sets of parentheses. The square root of the first term will lead off both parentheses. Then we have a plus and a minus. And then the square root of the second term, 3 and 3. Just like we have here. So, let me do these two examples for us. X squared minus 25. It's going to equal, I'm going to put my two sets of parentheses, the square root of the first term, x and x, plus and minus, square root of 25, 5 and 5. For B, 4z squared minus 1, that's a square. If this is a square and this is a square, the whole thing is a square. And it's a difference. So the square root of 4z squared would be 2z. It goes here and here. And it's going to be plus and minus the square root of 1, which is 1. So 1 and 1. Easy peasy, lemon squeezy. Evaluating a numerical expression. So we want to use a special product pattern to evaluate the expression 54 squared minus 48 squared. Well, according to our difference of two squares patterns, since these are squared, now notice they're not square numbers, but they actually show them squared, so that makes it a little bit easier for us. It's going to be 54 plus 48 times 54 minus 48, okay? Because the square root of 48 squared is 48. The square root of 54 squared is 54. So 54 plus 48, 8, and 4 is 12, and 9 is, plus 1 is 202. 54 minus 48 is going to be 6. So it looks like your answer is going to be 612. Well, I certainly hope that's right, because that's what I got when I did it this way. So that's another way we can look at, use these special product patterns to evaluate numerical types of expressions. Okay, so let's talk about when we squared binomials. Okay, so when we squared binomials, 3x minus 7 squared was going to be the square of the first, 9x squared, and then minus, because this is a minus, we multiplied these two together, then doubled it. So 3 times 7 is 21. 21 doubled is 42, so 42x. Plus, the last one's always positive, plus 7 squared is 49. Over here, I would have x squared plus 1 times x is x times 2 is 2x. Then plus, and then 1 squared is 1. Okay, so these are what we call perfect square trinomials because they're trinomials that result from squaring binomials. Just like the number 36 and 49 and 81 are perfect square numbers because they result from squaring smaller numbers. these are perfect squares. And we have to learn to recognize these. This first item is going to be a perfect square. This last item is a perfect square, right? It's checking the middle term that gets a little complicated. What do? We take the square root of the first term, which in this case would be the 3x. We take the square root of the second term, 49, which would be 7. If I multiply them together, just like when we were doing it before, if I multiply those together, I get 21x. And if I double it, I get 42x. Now, the sign doesn't really matter at this point, but as long as I have the 42x, this is going to be a perfect square trinomial. Okay, once again, square root of the first, square root of the third. Multiply them together and then double it. Do I get that middle term? If I do, I have a perfect square trinomial, and then I can take the shortcut. So let's take a look at the shortcut here. And the shortcut is basically we take the square root of the first term, right, which would be a in this case. The square root of the second term, which would be of the third term, which would be b, and the whole thing is just squared. And the sign that we use in the binomial is the same sign as our middle term. Pretty easy, right? You can look at these. Let's just go ahead and do an example here together. N squared plus 8n plus 16. Is this a perfect square trinomial? That's a square. 16 is a square. N, the square here is n. The square here is a 4. If I multiply those together, I get 4n, and then times 2 equals 8n. So this is a perfect square trinomial. So to factor this, I take the square root of the first, I take the n, I take this sign plus the square root of the last term, 4, and the whole thing is squared. That's the square root. Basically, this is the square root of this trinomial. Let's take a look at the second example here, 4x squared. Yes, it has a square root of 2x, and 9 has a square root of 3. If I multiply those together, I get 6x, and then times 2 is 12x. So this does check, 12x checks. So this is a perfect square trinomial, so I can use the shortcut. The square root of the first term, the sign of the middle term, so minus 3, the square root of the last term, quantity squared. Okay, don't forget to enclose the whole thing in parentheses and put the little square exponent up there. Solving a polynomial equation. Okay, so we've already looked at some solving of polynomial equations using the zero product property. So we're going to do the same thing here. This is a perfect square trinomial. 1/3 is the square root of this. X is the square root of this. So 1/3 double is 2/3. This is a perfect square trinomial. So we can go ahead and factor this into x plus 1/3 squared equals 0. And then using the zero product property, using the zero product property, I have the same thing here twice. So I don't really have to do it once because I have the same root here twice. X plus 1/3 times x plus 1/3. So zero product property says that one of those is going to equal 0. So in this case, x equals negative 1/3. Zero product property. Remember the zero product property, which we've already covered. Okay. That's it for now. I'll see you in class next time, and have a great rest of your day. Bye-bye.